Hello, welcome to the course on emerging domain electronics engineering. This is lecture 26, and in the last lecture we have seen how what is AM. Now we will see how the AM signals are generated and detection. So first we will see some numericals that we have already discussed some relationship in our last lecture. Now we are going to utilize those relationships for solving these numericals. So the first numerical says that the AM transmitter has a carrier power of 30 watts, means it is given that PT equals to 30 watts. The percentage modulation is 85%, means mu equals to 85%, means 0.85. So again this mu is less than 1. So mu is less than 1 means this is called as the under modulation. When mu equal to 1 it is a critical modulation, and when mu greater than 1 it is over modulation, which is avoided. So the question says that calculate the total power and the power in one sideband. So we must remember that the total power PT consists of basically carrier part plus the sideband part. Again in sideband we have PC plus P upper sideband and P lower sideband. So this carrier power we are aware AC square by 2, and P USB again we have calculated the relationship for P USB and P LSB. So this we need to find out the power in one of the sideband, because these powers are equal, because the amplitude was same for upper sideband and for lower sideband, which is mu AC by 2. So if the amplitude was same for both the components, then the power will be also same for upper sideband as well as for the lower sideband. So if we will see that this is the relationship PT equal to PC 1 plus mu square by 2, and PC was 30 as per the question. Now mu was 0.85. So if we will put in this particular relationship, then we will achieve that total transmitted power is nothing but 40.8 watt, 40.8. So the sideband power, which is PT minus PC, we can find out. PT was 40.8, PC was 30. So 40.8 minus 30, which is 10.8. So the total power, total sideband power is 10.8. But the question says that calculate the power in one of the sideband. So we must aware that P sideband in means in one sideband it is PSB by 2, or we can say this P upper sideband equals to P lower sideband equals to P sideband by 2. So half of 10.8 is 5.4 watt. So this much amount of power is in the sideband. Now we have the second question. An antenna has an impedance of 40 ohm. After that, an unmodulated AM signal produces a current of 4.8. The modulation is 90%. So we must write down these values, that as per the numerical R is 40 ohm. After that IC, which is 4.8 ampere. Next we have modulation index mu equals to 90%, which is around 0.9. Now we need to calculate the carrier power, the total power and the sideband power. So first we will calculate the carrier power, which is quite easy. PC equals to I square R. I is 4.8 square multiplied by R, which is 921.6 watt. Now with the help of this carrier current IC, if we will calculate what is the total transmitted current IT. So we have seen a relationship in our last lecture, IT equal to IC under root of 1 plus mu square by 2. Means if we have the modulation index mu, then we can calculate the transmitted current. So this transmitted current is around 5.7 ampere. So using this total transmitted current, we can calculate the transmitted power, which is Pt equal to IT square R. So this value comes around 1295 watt. Now the question says that calculate the sideband power. So as we are aware that the total power Pt equals to Pc plus Psb, so the sideband power will be nothing but Pt minus Pc. Pt minus Pc. Pt was 1295 watt, Pc was 921.6 watt. So the remaining is 373.4 watt is the total sideband power. If someone says that calculate the power in one of the sideband, then we just divide this by 2. So this comes out to be 186.7 watt. So this is the these are the numericals corresponding to AM. Now we have the generation, how the AM signals are generated. So these AM signals we just categorize as the low level generation technique or the low level AM generation and high level of AM generation. So we have this square law modulator. So first we will see what is the working of this square law modulator. So we have, this is the massive signal MT, this is the carrier signal CT, which is AC cos 2 pi FCT. This is called as the summer, or it is called as the adder also. At this particular node, both the signals MT and CT, they are just added. So after that it will result in a signal which is V1T. After that we are utilizing a device which is called as the square law device. So the role of this square law device, we can, if you will see here from this particular equation, equation number 1. So this output V2T is something K1 times of V1 plus K2 times of V1 square. This basically system performs the square of the input signal, which is V1. So we will achieve this V2T. After that, if we are utilizing the band pass filter, then we can achieve our AM signals. AM signal. So if we will start, first V1T, this signal is MT plus CT. So MT plus AC cos 2 pi FCT. Now if this V1T is passed through a square law device, then V2T will be K1 V1T plus K2 V1 square T. So we will put the value of V1, let's say this, in this first equation, and we achieve V2T. We just try to expand this equation. So we have this first term, this is our second term. Now just expand, this is square. So again we must have, let's say, 3 terms, 1, 2, 3. So as a result we have, let's say, 5 terms in this expression of V2T. Now if we are utilizing the band pass filter, so what happen is, it will basically pass, let's say if we will put a band pass filter having a frequency of Fc. So what happen is, these signals get eliminated, these get eliminated, we will see. So what is the role of this band pass filter? So basically if we observe our last term, so the last term of the above equation represents the desired AM signal, and the first 3 terms of the above equations are unwanted. We can clearly see this one and this one, these 3 terms are not required, because this is nothing but our message signal, this term is nothing but the square of the message signal, means there is no modulation, and in this third term we have only the carrier, means no information is there. So this third term is also unwanted. But in this last term we have the carrier and we have the message. So now this term is basically helpful for us because this is the modulation. So we can say this, the last term is basically a desired AM wave and the first three terms are just unwanted. So with the help of the band pass filter we can pass only the AM wave and we will eliminate the first three terms. So therefore the output of this circuit was St equal to K1T 1 plus 2 K2 by K1 MT cos 2 pi FCT. So we must remember that what is the generalized equation of AM? The generalized equation of AM is St equal to AC 1 plus Ka MT and cos 2 pi Fc. So we can clearly see this equation number 3 and equation number 4. We can match. This is the carrier part, same. This is message, same. These are the constant 2K2 by K1. Here this is constant. This is K1 AC. It is AC. Basically, this K1 AC is nothing but the amplitude of the carrier is somewhat further increased by a factor of K1. So with the help of this particular method, square law, with the help of this square law device, we can achieve the AM signals. So this is the generation technique of AM signals or the AM wave. Now we have the detection or demodulation. So the detection process or demodulation process is that we are recovering the signal back. Means what kind of signal? Our massive signal back from the modulated signal. So as per the definition of this demodulation or detection, the process of extracting an original massive signal. Here the original massive signal stands for MT, our baseband signal, from the modulated wave is known as the detection or the demodulation. So the circuit basically which demodulates the modulated wave is called as the demodulator. The circuit is known as the demodulator. So first we will see how this demodulation will work, how we can detect the signals. If we will see that these are the envelopes in AM, this one is the upper envelope, this one is the lower envelope. So this is the demodulator and our aim is just to achieve our massive signal back. This one was empty. So this whole task is performed by a circuit known as demodulator. So we have the following two detection techniques, or we have the two detectors available with us. One is the square law demodulator and one is the envelope detector. So first of all we will discuss what is square law demodulator. As we have already seen that what is the role of this square law device, means whatever signal we are transmitting, means whatever signal which is input for this square law device, it will produce a square of the input as per this relationship, which is K1 times V1 plus K2 times V1 square T. So if V1 T, this one was our input wave, so this square law device is basically performing the square. It is performing the square of V1 T as per this particular relationship. Then we will achieve, let us say, this first term, this is our second term, third term, fourth, fifth, sixth, and this is seventh and eighth terms. So now clearly we can say that this is the carrier having frequency Fc in the first term. Second, we have Fc plus Fm, and Fc minus Fm also we can achieve with the help of second term. Third term, no frequency is there, only a DC component. Fourth term, we have Fc, so we have already written Fc Fc here, but this is 2 times of Fc, like this. Here we have m square t, so that is nothing but 2 times of Fm. This again 2 times of Fm we have already written. Sorry, this is 2 times of Fm plus Fc. Similarly 2 times of Fm minus Fc, because it is in a product form. This next term we have mt here, so we have only the frequency which is Fm. From the last term we have 2 times of Fc and Fm, so I think we have written, or we can again write 2 times of Fc plus Fm and 2 times of Fc minus Fm. Now we need to select that what is the frequency of our interest. Our interest is to achieve our message signal back. So our message signal basically contains a frequency. If we will write down our message signal mt, this is am cos 2 pi fmt. So our interest is to achieve a frequency Fm, but we have these frequencies available. So if we can clearly see that what frequencies means which term we want, means we want this term having a frequency Fm, otherwise all the frequencies are different, all the frequencies are high. So if we will put a low pass filter at the output stage of the square law device, low pass filter having a cutoff frequency of Fm. So this low pass filter will pass the low frequency component, means having frequency Fm, those signal will be passed through the filter, and the frequencies and the components having the frequencies greater than Fm will be attenuated, means that component will not be passed through the filter. So in this way we can achieve our message signal back, which is K2 AC square m Ka into mt. This is nothing but the constant. Constant basically improves, it basically increases the amplitude of the message, but the frequency of the message signal will remain same, which is Fm. So this is the first technique, square law demodulator. Now we have the second technique, is called as the envelope detector. So this envelope detector, I think this kind of circuit we have already seen somewhere in the clampers. So what happens is the envelope detector, this form of the detector is the simplest form. So only required one single diode and further one resistor, one capacitor, means very low cost components are required to detect the AM signals. So the performance is adequate for the low cost AM broadcasting, but it does not meet the standards of other form of demodulation. So here what we can see, that if this is the AM signal we are receiving, then how can we modulate, how can we demodulate our signal from this kind of waveform? So as we can see that we have the diode, this diode. So this diode basically conducts in a forward direction, means whenever the current is positive or whenever the current is in this particular direction, so this diode will be on, otherwise this diode will be off. Now what happened during the first positive, means during the positive half, means this upper envelope, for this upper envelope what happened, this diode will act as a short circuit and the capacitor will be charged. So what we have, means after this particular diode we have, means this part is left, means this upper half is left. So if we will draw the waveform something like this, and finally some small peaks, and again something like this. So this is the output at this particular end, because we are utilizing the we are utilizing the single diode. We have seen in the rectification also, half wave rectification, the bidirectional current is converted to a unidirectional. So, after that we have the capacitor. So, we have the time constant for RC circuit. So, time constant for RC circuit tau equals to RC. So, what happened, the charging time constant tau C RC, and R is basically the internal resistance of the diode during forward bias. We must aware that during the forward bias the diode offers very small amount of resistance. So, this time constant is very low. So, what is the advantage of low time constant? That charging will be fast. Charging will be fast. After that we have, let us say, the discharging circuit, that tau D equals to RC. Now, this R is high in comparison with input resistance of the diode or the internal resistance of the diode. So, this time constant is very high, that means the discharging will be slow. The discharging of capacitor will be slow. So, what happen is, we will charge the capacitor something like this, but discharging is slow, again something like this. So, if we will clearly draw the waveform, then we will have something like this. Some spikes are there, but we have our waveform. This is the massive signal. We have one more circuitry, we can put the filter so that the waveform will become smooth. So, but at last we can say that our massive signal MT we are able to achieve. So, this is the detection technique, envelope detection technique, and this kind of circuit is known as the envelope detector circuit, which consists of a diode, capacitor and a resistor. So, after this detection, AM detection and generation, we will move to a new topic, which is the introduction to data communication. So, first of all, what is data communication? So, data communication refers to the transmission of the digital data between two or more computers that allows computer to exchange the data. The physical connection between the networked computing devices is established using the cable media or the wireless media. This is basically the channel, cable media, wired channel or the wireless channel. So, the best known computer network is the internet basically. So, a system of interconnected components and computerized peripherals, we will see what is peripherals, such as printers, is called as a computer network. This is called as a computer network, means the computer with their interconnected interconnected computers along with the peripherals, these are called as the computer network. Now, what are the characteristics of the data communication? So, for the effectiveness of any data communication system, there are some fundamental characteristics. So, the first one is the delivery. So, the delivery is basically that whatever the data you are transmitting, so the data should be delivered to the correct destination with the correct user, means it must receive at the correct destination side to the correct user. After that, the accuracy. The communication system should deliver the data accurately without introducing any error. So, the data may get corrupted during the transmission, because we are aware that noise is there inside the channel. So, maybe what happen is, due to that noise, some part of information, some data may get corrupted. So, the accuracy is again the main characteristics. So, this affecting the accuracy of the delivered data due to this corrupted, due to the channel due to the noise present in the channel. Next is the timeliness. Now, what happen is, for the real time audio and video signals or what we can say as the audio and video data has to be delivered timely manner without any delay. Means if we are, let us say, communicating, and if someone is giving some speech or some video is transmitting, so it must be basically received at proper instant of time, otherwise there will be basically mismatching in the voice, in mismatching in the video also. So such a data delivery is called as the time transmission of data, timely transmission of data. Next is the jitter. So jitter, it is the basically the variation in the packet arrival time. So uneven jitter may affect the timeliness of the data being transmitted. Means, let us say if we are transmitting, first packet is transmitted. So what happen is, if first packet is received after, let us say, a large number of time, and we received second packet before the first packet, then again it is called the jitter. So timely arrival of the packet is basically the important characteristics of the data communication. Now we have the data communication between the devices. We have, let us say, router, this is the internet, these routers are connected with each other with the help of some topology. We have the ATM switch over here, high speed link, this is a high speed link, firewall, host, private virtual area network. We have the LAN PCs, they are connected to the Ethernet switch. This is the information server, which is again connected to the internet Ethernet switch, and with the help of high speed link it is connected to a network, something like this. So networks basically provides the networking service between the two entities. The communication between the end point uses a protocol. We will see in our next slides that what is protocol. These are a set of rules basically, which basically governs good communication, good data communication. So first we have the components of data communication. First component is a message. So message, basically we have seen the information or the data which is required to be communicated by the sender to the receiver. Now the sender, basically the sender is any device that is capable of sending the data, the information, the message. Now the receiver which is basically capable, which is able to communicate basically with the sender, and it can receive the signal which the sender has transmitted. Now the transmission medium, as we are aware, the transmission medium, maybe it is a wired or the wireless medium. So it is a path by which the message travels from the sender to the receiver. It can be wired or wireless, and many subtypes, means it is a mixing of both wired as well as wireless also. Now the very important thing, which is the protocol. So it is a set of rules that governs the data communication. So a protocol is necessary in data communication, without which the communicating entities are like two persons, they are talking to each other, but they are talking in a different language. One person is talking in, let us say, different language, second is in different language, and both the persons, they are not able to understand each other because their languages are different. So this protocol is necessary. Now we have, let us say, a simplified data communication model which consists of source, transmitter, this transmission system, receiver, and the destination. So we have a general example. So as a source we have the workstation, modem, which act as the transmitter. We have the public telephone network, PTN. We have the modem again, which is placed at the receiver side. So here the role of modem is to perform the modulation, and here it will be performing the demodulation, and this is the server. Server is the destination. So again, this is in terms of the waveform, the digital bit. After that, for the transmission we need to convert this digital bit into the analog one. After that, analog signals are received by the receiver, and again it will be converted to the digital bit stream, and it will be delivered to the destination. Goals, these are the goals, that resource sharing such as the printer and storage devices, exchange of information by means of emails and file transfer protocols, IP phones, video conferencing, parallel computing and instant messaging. These are the applications of networking. These are the references. Thank you.